All right, in this video, we're going to be looking at inheritance. And inheritance is just a neat property of any object-oriented language that allows you to build classes on top of each other. It allows you to share variables and functions from one class to another. If you've ever played Minecraft, you know that the game is made up mostly of blocks. And all of these blocks have certain things in common. Like every block is going to have a name. Every block is going to have a position. Every block is going to have a texture, a graphic that's wrapped around it. But from there are other different types of blocks. Some are wood, and there are several different types of wood. And so wood block might be a subclass of block, and block may be the main class. There are other blocks that are liquid. There are blocks that are affected by gravity. And so these blocks may be divided up into different classes, but they all stem from a base class that is just the block. And so that's one example. Here's another example. I'm going to create a class called item. And the item class is just going to represent a generic item in a random video game. So we'll say that any item in this game is going to have a name, and any item is going to have a price or a value. And this can be said of any item in the game. And then from that, let's say I want to add weapons to my game. And weapons are a type of item. Then I would write class weapon colon, and then I'm going to write the word public item. And from here, the rest of this class is the same. I forgot my semicolons. The weapon class will have a name and a value. It will inherit them from the item class, and then it can provide a few variables of its own. Something like that. I'm going to go ahead and make everything public, just so it's easier to work with. In main, we will create an instance of weapon, and then I will show you that it does have access to these item variables. So we'll say weapon w, and then I can say w dot name equals sword. And you can see that it turns purple. It recognizes that name is a variable that does belong to this class. It inherits it from the item class above. Variables are not the only thing that is inherited. Anything can be inherited. So let's look at how functions are inherited. Let's say I have a display function, and I will just write some cout statements in here. And I'll do the same thing for the weapon class. I'm going to go ahead and plug in a few more values for my weapon. So I will set the value and the damage. And now we will call display and see what we get. So I see that I get damage and I get attack speed, but I don't get the name and the value. So what you can do is call display of the parent class. This is the parent class and this is the child class, or sometimes called the base class and the subclass, or derived class. There's lots of different names for this, but what you would do is write the name of the parent class and then use the scope resolution operator to indicate that you want to call that version of display. And I'm doing that as the first line of this function. So it will call display from above. I'll see the name and the value, and then it will run these two cout statements. And you can echo this trend if we were to derive from weapon. If you wanted to make another class for swords or spears or whatever, you could do that and then display those properties. You could call the weapons display, it would call the items display, and you can just echo that trend. So let's try it now. And now you can see we get all of the properties from both classes. If you wanted to derive a third time, let's say we want to make a class for the sword. If I want to derive from weapon, which is derived from item, I don't have to put item here. I'm only going to put public weapon. And now this sword will have all of these properties. It will have all of these properties. And then I can put whatever I want for the sword class specifically inside of here. Let's look at constructors. Let's say I have an item constructor that is going to allow me to set these two values when I create the item. I'm going to start by making a default constructor. And then I will create a 2-argument constructor for the name and the value. I'm going to go ahead and use an initialization list. Instead of doing it inside the braces here, I will say name is the name and value is the value. That's called an initialization list. You also need a colon right there. And that's good for my item class, but what if I want to do the same thing for my weapon class? Let's say I want to create a weapon, and I want a constructor that fills out all 4 values. So we're going to have a name, a value to fill in these 2, and then we will have a damage and an attack speed. So 4 arguments: name, value, damage, and attack speed. Now the name and the value are going to be handled by the item constructor. And so I can take advantage of this constructor I've written up here. And then I will set the damage and the attack speed down here in the weapon constructor. So to do that, I can call my item constructor by putting a colon here, typing the word item, and passing in the name and the value. And then I can proceed with setting my weapon properties, and I could do this with an initialization list, or I could do it the typical way. We could say this damage equals damage. And this attack speed equals AS. I got lazy right there. And now down in main, we can take advantage of those constructors. Instead of having all of this mess, we can set it from the get-go. Name, sword, value, 1099. And with NetBeans, if you can't remember what your next data type is, you can hold down Control and press P right after an argument, and it will show you what your constructor is expecting. I can see it's expecting a float right here, and then I have int for damage and float for attack speed. So that's a helpful little tool tip. And you can see it works just fine. And you can continue this trend. You can call the constructor of a parent class just by putting a colon on the end of your constructor, and then give the name and pass in the values there. And this saves you a lot of time. You don't have to write the same code over and over again. Inheritance also provides you a great way of organizing your code. So if you're working on teams, you can pass off different classes to different team members, and you can all work together that way without working on the exact same document. Inheritance also leads into polymorphism, which we'll be talking about in the future. So make sure you have a good handle on this because it gets a little more complicated and a lot more fun, and leads into some of the really nice, powerful features of C++.